Welcome to the review and preview problems 8.116 to 8.122 in the CCG book. 8.116 says use what you know about the area and circumference of circles to answer the questions below. Show all of your work and leave answers in terms of pi. So I know that the area of a circle is equal to pi times the radius squared, and I know that the circumference of the circle is equal to 2 pi r. If the radius of the circle is 14 units, what is the circumference? So circumference is equal to 2 times pi times the radius, which they told us was 14. So our circumference in terms of pi is 28 pi units. Our area is pi r squared, pi times 14 squared is equal to 196 pi units squared. If a circle has a diameter of 10, what is the circumference? If the diameter is 10, I know that the radius is half of the diameter. So diameter divided by 2 equals my radius. So 10 divided by 2 equals 5. My circumference would be 2 times the radius, pi, which is 10 pi. My area would be pi times the radius squared, so 25 pi units squared. Don't forget your units on circumference as well. If a circle has a circumference of 100 units, well, I know circumference is 2 pi r, so I can set that equal to 100 pi. I can divide by 2 pi, so my radius is 50. In order to find my area, I can plug that radius in. So area equals pi times my radius squared. So 50 squared would give me 2,500 pi units squared. If a circle has a circumference, C, so circumference equals 2 pi r, what is its area in terms of C? So the first thing we need to do is we need to solve our formula over here for the radius. So I'm going to divide by 2 pi. So the radius is equivalent to the circumference divided by 2 pi. I then am going to substitute that into my area formula, which is pi times the radius squared. So I can simplify that out by writing pi over 1, c over 2 pi, c over 2 pi, I notice that 2 times 2 is 4 in the denominator. This pi and this pi cancel out, so I'm left with 1 pi in the denominator. C times c is c squared. So my area is equal to c squared over 4 pi units squared. 8-117 says in the year 2000, a share of Jiffy stock was worth $20. So in the year 2000, I have some stock that was worth $20. In the year 2010, the stock was worth $50. What was the annual multiplier and the annual percent of increase? So some keywords that stand out to me is we have a percent increase. This tells me that I'm going to need a number that is greater than 1. It also stands out to me that I need an annual multiplier. If I need an annual multiplier, this tells me that I'm looking at an exponential equation, y equals ab to the x power. So I can take these two ordered pairs, essentially, and plug them into a system and solve. I know my y value is 20. I know my x value is 2,000. I can also use 0 and 10 because these are 10 years apart. So I know 10 years later, my output was 50. My output was 50, and we'll use 10 as our exponent to kind of save on the amount of numbers. I then can get a by itself by dividing by b to the 10th power. So 50 over b to the 10th is equal to my a. I then can use substitution and take what I know a equals and plug it in my other equation for a. So 20 equals 50 over b to the 10th times b to the 0. So anything to the 0 power is 1. So we get 20 equals 50 over b to the 10th. Inverse operations to get b to the 10th out of the denominator. So we get b to the 10th times 20 equals 50. Divide by 20. B to the 10th power equals 5/2. The inverse of something to the 10th power is taking the 10th root of both sides. When we plug that into our calculator, b is equal to 1.0959, which rounds up to 1.096. B represents our multiplier. And then we know our multiplier, we add 1 to it because it's a percent increase. So if they asked us for our actual percentage and we move our decimal 2 jumps to the left, our percentage is a 9.6% increase. 8-118, Larry started to set up a proof to show that if AB is perpendicular to DE, so if AB is perpendicular to DE, so we say this is a 90-degree angle, because that's the definition of perpendicular. DE is the diameter of circle C. Then AF is congruent to FB. Examine this work below and complete the missing statements. So statement number 1 is our given. So that is what the book told us. Then he states that angle AFC and angle BFC are right angles. And that is the definition of perpendicular. FC is congruent to FC, would be our reflexive property, because that's a shared side. AC is equal to BC is the definition of a circle, because all radii must be equal. They then have HL congruency. So by the hypotenuse and a leg, which we previously here and here stated was equal, we can say that triangle AFC is congruent to triangle BFC. Then we can conclude that line segment AF is congruent to line segment FB, because if we have congruent triangles, it implies we have congruent parts. Match each regular polygon named on the left with a statement about its qualities listed on the right. A regular hexagon. So remember, when we talk about central angles, exterior angles, interior angles, for any polygon, our exterior angles equal 360 degrees. So on these two problems where they say our exterior angle is 90 degrees, we could take 360, divide that by 90, and we would know that we have a four-sided figure. On number 4, it said the exterior angle is 120. So if we take 360 and divide it by 120, we know that we are working with a three-sided figure. So then, looking over at our choices, a three-sided figure we could match with number 4 because it's an equilateral triangle. A hexagon we know has 6 sides, a decagon has 10 sides, and a square has 4 sides. So we could match number 2 with letter D because we know it has 4 sides. The central angle of a polygon, we can find the central angle by doing 360 divided by the number of sides, or we can find the number of sides by doing 360 divided by the central angle. So we know that this shape that has a central angle of 36 degrees matches with our regular decagon. Our interior angle measure of 120, if we think of our interior angle measure for our polygon, it is this angle right here, which adds up to 180. So if you take 180 and subtract out 120, you could find your central angle of 40. If you do 360 divided by 40, you would know that it has 9 sides. But in this case, if you do your subtraction correctly, 180 minus 120 is not 40, it's actually 60. So when you take 360 and divide by 60, you do in fact get 6 sides, which matches with our hexagon. Exam 8-120, examine the graph of f of x below. Use the graph to find the following values. F of 1. So remember, this value inside this parenthesis means x. So when x is 1, where does it intersect our graph? F of 1 is equal to -3. So you want to see, what is the y value when x is 1? What is the y value when x is 0? When x is 0, our y value, or our y-intercept, is equal to -4. This time we're going to look for x if f of x is 4. So if our y value is 4, what is our x? Well, it is almost 3, and it is almost -3. So we could guess about -2.8 and about +2.8. Letter D says x if f of x is equal to 0. So if y equals 0, what are our x values? Well, it happens to be our x-intercepts, so 2 and -2. 8-121 says, examine the relationship that exists in the diagram below. Find the measures of angle A, B, C, and D. Remember that you can find the angles in any order depending upon the angle relationships you use. So looking at these, the first thing that jumps out to me are these two angles right here. And I know that these two angles are supplementary angles. And I know that 180 is equal to 112 plus D. So I can solve for D using my inverse operations, and I know that D is 68 degrees. So I always go ahead and write them where my letter is in case it helps me find another one. Looking at angles D and C, these are two parallel lines, so I have alternate interior angles, which would make angle C 68 degrees as well. Looking at A and this angle 97, I know that these are corresponding angles. So A is equal to 97 degrees. And then angle B is the last angle I need to figure out. If this is 97 degrees, I can tell I'm looking at a triangle here, so I know a triangle equals 180. I know angle A is 97. This angle right here is vertical to D, so I know that angle is 68. Plus angle B, when I use my subtraction, I know that B is equal to 15 degrees. 8-122 is a multiple choice question. It says, how many cubes with edge of 1 length would fit into a cube with the edge of 3 lengths? So looking at this, if I had 3 cubes, I know a cube is the same, both dimensions. So looking at this side of my cube, I know I would have 9 blocks on this face. I know I should have 9 blocks on the top as well, and on the side. So I could count up all those blocks and see that it's 27, or I could take my length times my width times my height, 3 times 3 times 3, and also get 27.